Okay, let's prove the theorem states the sum of the measures of the interior angles of a triangle is 180 degrees. 180 degrees. Now let's start with for any arbitrary triangle ABC, and because we don't know what exact the measurements of the sum of the interior angles, we just say x for that. So x degrees for the sum of these three angles. Then for any arbitrary point on any side, so let's just choose AB without loss of generality and just choose any point D. Then when you think the angle sum of these three angles for that triangle, then it should be x2, right? And for the same reason, for the other triangle, that angle BFG, the sum must be also x degrees, right? Okay, so we just know 2x is in there. Then when you add all these 6 angles all together, the measurements, then it should be double of x because each triangle has x degrees and x degrees, so altogether 2x degrees. Then let's just look at these two angles only, D and G. Then it's a straight line because it came from a line segment AB, so that sum must be 180 degrees. And for angle ABEF, we're adding these four angles ABEF, then that is same as angle ABC because EF is just a partition of angle C. So this should be same as angle sum of these three angle measurements, and we assume that the sum must be x. So these four angles A, B, E, F, when you add them, it should be x. So in the beginning, we know that the sum of these 6 angle measurements is 2x. And we know that this is 180 and the other 4 is x. So when you put them together, when you're adding these two triangles, sum of inner angles is 2x, but when we rearrange them, the sum of these four angles is x, and sum of D and G is 180. So by subtracting x from both sides, we're going to get x equals 180, which is the sum of that three interior angles. So we can claim that sum of triangle, the interior angles of triangle should be 180 degrees. And it's true for, doesn't matter which triangle we choose. So we can just do exact arguments for whatever shapes. So we can claim that this statement is true for any triangle.